Welcome to the second part of the R tutorial on one-way ANOVA. In the previous video, we have performed the analysis of variance on the results of a one-factor experiment. In this video, we are going to build a table with the mean, the standard deviation, and the number of observations for each treatment, and then we are going to perform the Tukey's test. The data file we are working with presents the results of the release of radon in showers with different diameters. You can find the links for the data and the R code files in the description of this video. So let's start. To generate a table with the resulting mean standard deviation for each condition, we are going to use the dplyr library. If you have never used it before, maybe you will need to install the package first using the code install package dplyr. Once you have an R package installed, you won't need to do it again. As I have already mine installed, I just need to load the dplyr package using the library function. The next step is to create a table with the summarized data using the functions groupBy and summarize. We are going to group the results of the radon data file by the variable d, the shower diameter. In the new dataset that I have called radon summary, we are going to have the mean, the standard deviation, and the count, the number of observations from each treatment. The response variable is the radon released, the double R. We must use the view function to open the new table, so let's run it. The summarized table presents the mean and the standard deviation of the results from the radon released for each diameter. We can also see that we have 4 observations for each treatment. Now let's compare the results using Tukey's test. The Tukey's test will run the results of the analysis of variance we did in the previous video of this tutorial and that we have stored on the object called ANOVA-RR. The output of the Tukey's test function shows the differences between the paired means of all possible combinations of treatments with their respective p-value. Differences with p-value lower than the level of significance alpha, usually 0.05, are statistically different. For instance, the difference between the results at diameter 0.51 and 0.37 is not significant, meaning they are statistically equal. On the other hand, the difference between the results at diameters 0.71 and 0.37 is significant, meaning they are statistically different. We can use this result to attribute the superscript ladders to each treatment to indicate differences in Tukey's test. The rules are simple. The highest value receives the letter A. Means that have no significant difference receive the same ladder. For instance, as there is no significant difference between the results at 0.51 and 0.37 millimeters, they receive the letter A. The next comparison is between the results at 0.37 and 0.71 millimeters. As they are different, they must receive a different ladder, so 0.71 receives the letter B, and so on. The final results are A, AB, B, B, C, and C. We can add them to the summarized table of the results by creating a new column that I have called Tukey. The use of the superscript ladders has simple rules. However, attributing the correct ladders can be challenging. If you need help, the next video of this series presents an easy-to-follow step-by-step tutorial on the superscript ladders. Now, we can save the summarized table as a CSV file. The function is the write CSV, where the first argument is the object we are saving and the second argument is the file name. Before running the code, we must set the folder to save the file. We can do it by selecting the folder in the Data File tab. I have mine already selected. Click on the little gear in the right side and set as working directory. Now let's save it. And here we have the CSV file. You can use it to build a table with the final presentation of the results or use the information to create a beautiful plot. The third video of this series presents a step-by-step tutorial on using superscript ladders to indicate significant differences in the case test. And the last video is how to build the publication grade bar plot for the final presentation of the results. If this video are useful to you, don't forget to like it and subscribe to the channel. Thanks for watching, and I see you next time.